What is up, most distinguished patrons of this channel? Today we are dealing with part 2 of how to TIG weld. So that's what we're going to be tackling today. Let's get into it. If you haven't seen part 1 in this series, you probably should go back and watch that so that we're all on the same page. A lot of what we're going to be discussing in this video and moving forward is going to have very little details, sparse on the details, on stuff that was covered in the first video. That's why I did such a long video to cover the basics of machines and TIG torches and all of that. So I'm making the probably idiotic assumption that you're on the same page as I am and you already watched the first video. So anyways, watch it if you haven't. Otherwise, I guess I don't care. You're here, right? So what we're going to be covering today is the basics of starting an arc, the basics of PPE, and talk a little bit about welding hoods and that sort of stuff. So the first thing we're going to talk about is the glove situation. A lot of people try and TIG weld with gloves like this, which are more or less designed for MIG use. And I got news for you, buddy. Maybe on your torch holding hand, you can use a thick glove. But if you use a glove like that, instead of something thinner like a TIG specific glove on your feeding hand, so the hand that you feed filler, you're going to have all sorts of issues because you just don't have the feeling of this little small rod in your hand. And how are you going to feed this if you're wearing like an oven mitt, if you get what I'm saying? So my recommendation, everyone has Harbor Freights near them if you're in the United States. Otherwise, try Amazon or whatever you have in your country. Get a thin pair of gloves. My personal favorite are the Tillman Deerskin. This is a 25BXL. I don't know where you can get these locally. I generally buy them online. To me, this is the best TIG glove I've ever used. If you got a recommendation as you're watching this, feel free to leave it. These Harbor Freight ones aren't bad. They're stitched a lot more than the Tillmans, which makes it a little bit less sensitive for what you're feeling, but they're okay, and they're cheap. They're like 15 bucks. Now, TIG is one of the very few processes that you can get away with running gloves like this. Case in point, don't do dual shield wire welding with these on, or you're going to blister your knuckle. In case you're wondering what the injury is here, I blistered my knuckle because I was an idiot and decided to wear a glove. Actually, it might be this glove right here. Yeah, the heat mark matches the knuckle right there. Anyways, I smoked my knuckle. So TIG, use these gloves only for TIG. Do not weld anything else with them. You will blister your knuckles or burn your fingers. With that out of the way, I get it. You have your machine, you're excited to use it, and you want to learn how to start the arc and start welding. So in order to do that, obviously you need your TIG torch, you need to have your tungsten. You need to sharpen your tungsten properly. And I'm going to put up a close-up picture of these tungstens where we can take a look at them. So here we have 3 different tungstens with 3 different problems. Let's start out looking at the one with the black line. That has a fine point on it, so the point's fine, but you notice how that area behind the point is ground down with a bunch of scratches versus the rest of the shaft is nicely polished or smooth. You want to avoid doing this. Now, this was my own act of stupidity. Basically, the tungsten was contaminated and I used a grinder to grind it down, all that material off the surface, and it works. Like what you see there will work. The problem is, without that micro polished shaft on it, you're likely, especially at lower amperages, to have the arc wander off of the side of the tungsten and it affects the arc cone. So if you ever dip something bad enough to where the molten material gets onto the shaft, not just the point, just cut it off and then regrind the point. Leave that micro polished shaft on it. Now the red marked one clearly has been dipped. You can see the point doesn't exist. This is more of a blunt tip, which is more popular and works better with aluminum. And we're not talking about aluminum welding here, but if your tungsten looks like this, cut off the end, resharpen it so it's good. Now the green tungsten to an untrained eye seems to be just fine. It's got a point, the shaft is kind of polished, it doesn't look too bad, but do you see that gray area right behind the taper? That is metal contamination on the tungsten. you either want to polish that off or just cut it off above there. And I know I'm splitting hairs here, but I'm not joking. If you were to try and weld something with that tungsten, especially at low amperage, that material that's on there that doesn't look like contamination will affect the arc stability, the arc start, and for aluminum welding in particular, aluminum because it welds on AC, you're going to have an arc wandering issue where it's going to want to wander up higher on the tungsten to that rather than the point. Now, as far as what to use to grind these, I personally use a bench grinder that I only use for tungsten. It's a little one with like a 2.5-inch wheel. Technically, you can use any bench grinder to sharpen these. The one issue you want to be aware of is metal contamination. If you impart a bunch of steel dust or aluminum dust while you're grinding these, because let's face it, grinders leave a pretty poor surface finish, well, that's going to be in the tungsten and it will affect the arc start and the stability of the arc because it's going to fuse to the tungsten or contaminate your weld. So generally speaking, you should use a wheel or something dedicated just for tungsten use. Now at my job, I use a flat diamond disc that I have on a 4.5-inch grinder, and I only use that to sharpen tungstens, and that works really good. That's what I would recommend if you're in the market. It'll save you a lot of money over one of those self-contained tungsten sharpeners. Honestly, for the average person, those are a lot of money for not a whole lot gained. I would just use a diamond wheel on an angle grinder. It produces a very flat, very clean angle, and the arc starts are the best you're pretty much going to get with that, especially over a bench grinder. Now here are some pre-sold tungstens that are sharpened. You can see how that shaft is nicely polished and the tips or the angle is also nicely polished. Now when you sharpen these, you want the sharpening marks to go more or less from the point to the shaft, so straight lines in line with the tungsten itself. If you have swirl marks because you're pushing these into an angle grinder at an angle to the disc where it's swirling the tungsten, that's bad because you're going to have poor arc starts because the arc is going to want to wander from like halfway up the bevel and start there. So make sure that you're sharpening that in line with the direction that the stone or whatever you're using to sharpen moves. You don't want those spiral scratches on there, and the finer finish you have, the better. You don't have to polish them. That's really going too far. I mean, it maybe if you're using 1/16 tungsten and you're welding like, I don't know, 010 stainless or something super thin, you could get a little bit better arc start and better stability. But above about 20 amps, as long as you got a decent finish, you're fine. Now, as far as diameters go, my personal recommendation would be to stick with 3/32 tungstens. They will handle anywhere from 5 to 10 amps all the way up to 200 on DC. If you're welding on AC at 200, you'd probably want to go up to 1/8-inch tungsten, but for steel and everything else, the 332 will do everything that you really want. As far as the type of tungsten, I personally run 2% lanthanated. I would recommend against 2% thoriated or anything that has thorium in it. It's radioactive and you don't want that dust around your shop. Pure tungsten, green tungsten is also not worth buying. There's all sorts of other secret herb and spices like the E3 and all of those. You can buy those, but I don't know that they really work better than 2% lanthanated. That's what I use, and I just buy them on Amazon from, I believe it's MTS Tungsten. All right, let's move on. It goes without saying, sharp and clean means sharp and clean. Unless you're talking aluminum for all stainless steel, all of that, you want a sharp pointed tungsten. And if it looks like it has crap on it, like you contaminated and dipped it, cut the tungsten off, resharpen it. When you have all that crap on the tip of the tungsten, it's going to affect the arc stability, the arc cone, and you're more likely, especially above 120 amps, to produce undercut on the side of the weld or on the base material that you don't want. So keep it clean, keep it sharp. And I understand that when you're learning to do this, it's extremely difficult to not dip your tungsten. You're going to spend more time grinding your tungsten in your first probably 40 hours of TIG welding than doing anything else. So that's part of the learning curve. And speaking of the learning curve, one of the things you guys got to understand, and I'm not trying to sugarcoat this, TIG welding is a very tedious, slow process to learn because it all comes down to hand-eye coordination. Now, I'm going to give you a ton of tips in this series to really help you understand what you're doing, but you have to understand this is not something that overnight you're a miracle worker and you can learn it. It takes repetition. Think of it like learning to ride a bicycle or balancing a basketball on your hand, on your finger. You're not that good at it at first. After a week, you're really not that good at it. After 6 months to 8 months, you're getting pretty good. That's the same with TIG. The great news is that the learning curve with TIG is very steep at the start, but once you can run a straight, flat, consistent bead on steel, you can do that in pretty much any position, including up, vertical up and overhead easily, far easier, I feel, than most of the other welding processes. Not to mention it opens up a tremendous door to doing repairs on small items. Parts of a machinery, roll cages, anything you can pretty much imagine, you can weld with the TIG process and put down high quality welds, which is awesome. So it is worthwhile knowing. I'm just being upfront about the steep learning curve. Don't quit unless if you have 200 hours of practice in and it's not for you, quit then. Don't quit before then. So speaking of material, I'm a little bit of a stickler when it comes to material and teaching people a TIG weld. When I learned the TIG weld, I was only given sheet metal, like this stuff back here, like 1/16. The problem I have with that is it doesn't teach you to make a molten puddle very easily, I guess. It induces frustration because you just tend to burn through it. So what I generally teach people, and what I'm going to recommend for you, is find something somewhere between 1/8 inch and maybe 1/4 inch. This is 1/4 inch. This is what we're going to be using. That way you learn to manipulate a puddle and create it and make it big, make it small, and you're not worrying and putting in your brain making holes and melting through. So a little bit thicker for the first, I don't know, week or two isn't the end of the world. One of the viewers of this channel on part 1 had mentioned this, and I'm going to take his advice and mention it in this video as well. And the welding helmet you choose to use with TIG does make a difference in what you're capable of doing. This is one of the few instances that I can genuinely say spending more money to get a better welding hood with better clarity will make a difference. In a lot of cases with MIG and stick, all of that, it's not a huge like deal breaker per se, but with TIG, where all the small variables matter, we're holding very tight tolerances with the tungsten to the workpiece and all of that, a little bit extra will help you. I personally recommend Lincoln Viking 4350, which is what this is. This is actually the advanced version, or an ESAB Sentinel A60, or the I think it's 40 or 50, 30, somewhere in there. The clarity of those two hoods are exceptional. It will make a difference with how fast you can pick up TIG and how fast you progress. Now, I get it, not everyone has a budget for this. If you are at a little bit lower of a budget, look for something that says 4C for lens technology. Now, there's plenty of them on Amazon that'll tell you that, and then when you look through this or the ESAB, they look way better. So marketing is marketing, guys. You got to just find something with a decent color clarity to it. Look for a 4C lens, and hopefully they're not BSing you like some of them out there. And speaking of vision, I've taught a lot of people how to TIG weld, and I got to be honest with you, If you haven't been to the eye doctor recently and you're above 30 years of age and you're nearsighted or farsighted and your vision isn't what it used to be, you probably should go to an eye doctor and get your eyes checked. Because again, we're dealing in such small tolerances and such small welds. If you cannot see good at the distance you're viewing everything at, you will not be able to make decent welds. Now, I say that kind of half-assed joking because when you get to a decent enough skill level, you literally can make a good looking weld will probably not even looking at it, okay, because of muscle memory. But when you're trying to learn and you're trying to understand what's going on, a lack of clarity is going to be extremely difficult to work with if your eyesight is bad because you don't know what you're looking at. When you get experience, like things like the light output of the TIG arc tells you arc gap. You don't have to visually see it, but without developing that first, you do need to visually see it to understand what the hell's going on. So if you can't see shit, you're in trouble. A good way to look at it to determine if you can see is put your welding hood on and in the undarkened state, put a dollar bill on the plate and observe it from the distance that you normally would weld from. If you can't read the serial number and all the details on that bill, I mean, the anti-counterfeiting measures, who cares about that? That's so small you probably can't. But if you can't see all the details, you need glasses or a cheater lens in your hood to where you can do this, because vision, it's like 50% vision on the learning curve. You need it to get good. I'm going to have actual arc footage of all of these arc starts so that we're all on the same page, and that'll be in a minute, but we need to discuss how you start the arc. So with your TIG torch in your hand, in the case of high frequency start, what you do, I personally do this, I touch the tungsten to the plate to get a depth or basically a clearance of how far the tungsten is to the plate, and I just rock it off of it a little bit. Then I depress the foot pedal, start the arc, and slowly ramp up the amperage until a molten puddle appears. I find that touching the tungsten to the work and lifting it gives me a exact proper arc start. You want to aim for around 1/16 of a arc gap, or whatever your filler rod is. That's about the arc gap you want to run, roughly. But that always helps me. It's like a mental checklist thing. Okay, I'm in position, ready to weld. Now I'm going to have a whole video on hand positioning, but one thing I want to show you is this gas cup here, this gas lens, happens to set the tungsten right at about the correct distance where I just rest it in my hand, like kind of like a cigar or something, and I can just weld and maintain the arc gap without even thinking of it. And that's one of the things you're going to find is extremely helpful. You do not want to be the guy who's holding this torch without your elbow or arm on anything and trying to freehand it. You can see, and I'll even run a bead here, a simulated bead. See how much that's bobbing up and down? Now watch this. Much better. And I can use a natural arc on my wrist to my benefit. So you got to get this in your hand in the correct position, maintain your arc gap. Now for lift arc start, it's a little bit different than obviously high frequency. You generally want to have your tungsten a little bit closer to the cup, and the easiest way would be to touch the cup, touch the tungsten to the plate and rock it back, and then move your tungsten in position to weld. You can, depending on your machine, just touch and go. A better way, on most machines, better machines, you can create an arc gap there and just swipe between the plate and the tungsten with your filler material, and that will start the arc on its own, and it will often prevent tungsten contamination. And I will show you that as well. That's my preferred method rather than touching and going. Now I'll mention something here super important. If you have a cheaper machine, what will happen is they function more like a scratch start than a lift arc. They claim they're lift arc, but what they do is the tungsten is charged at whatever your amperage is, and then that you set the machine at, and the second you touch it, you more or less have that 160 amps there. Okay, well, what happens is with those types of machines, you're very high likelihood of touching it and sticking, melting the tungsten straight to the material. So if you have one of those machines that claims to be lift arc but doesn't, you're going to have to use that functioning like scratch start instead. And proper lift start, you won't melt the tungsten to the base material, okay? Now for scratch start, this is for you guys that are way old school where you're trying to use like a dial arc 250 or some other welder and you hook the TIG rig with a gas valve to it and you want a TIG weld. Well, for you guys, you have to do something a little bit different. Much like a stick rod, you're gonna have to bring the tungsten down very quickly, just like a match, touch it and bring it to an arc gap. Or again, my preferred method is to use the filler material and swipe it real fast between the tungsten and the workpiece. Expect to be frustrated because you're going to melt your filler rod, you're going to melt the base material, you're probably going to have the tungsten stick to something. It's going to be frustrating. And that's why TIG is one of those things that high frequency or even lift arc, proper lift arc, will save you a tremendous amount of frustration in starting the arc. And that's what I would recommend, but I get it. Some of you guys don't have the budget for it, and I'm here to help you still. So I think I covered enough about that. Let's go to arc footage and discuss the high frequency start. To start things off, here we have high frequency start. I got about a 1 millimeter, a little bit more arc gap, about 1/16 somewhere in there. All I do is depress the pedal, it automatically starts the arc, and as I ramp up in amperage, you can see the cone gets wider and it gets smaller as I let off the pedal. This is high frequency start. It's very easy to start the arc with this process. Now you saw that little piece that spit off, that's because the material still had mill scale on it and wasn't perfectly clean. Clean your material. TIG does not weld well through contaminants. Very clean arc start there again. Very easy starting process. That's what you should be seeing if you're going to start the arc. Amperage wise, the highest end was 150 and the low end was about 10 amps. So here we have lift start. I'm going to try and start the arc and things didn't go quite well. Watch. I don't know if you saw that, but the rod more or less stuck to the plate and it contaminated the tungsten. So guess what? I had to take this off and grind it. So I'm using 60 amps here and no foot pedal. So once the arc starts, it's exactly at 60 amps. You can technically use a foot pedal with most machines. If you're doing some kind of scratch start or older machine, you won't be able to. So there we had a perfect arc start, no contamination, everything's working great. Now to cut the arc out, because I'm not using a foot pedal, I have to lengthen the arc, so you're best off snapping out of it as fast as possible. Let's do that again. So that started pretty good. It would have been a little bit easier to start if I was actually holding the TIG torch, but you got to do what you got to do to film this stuff. And again, snapped out of the arc. That's exactly what you want to do lift arc start without a foot pedal. So here's a fun video clip. You can all laugh at my stupidity. I switched the machine to basically stick mode thinking, oh, I'll show scratch start and just start the arc just like lift arc, but I wasn't thinking it shuts the gas valve off, so I had no gas flow. And you can watch the arc starts just like lift arc when you swipe it with the filler, but with no gas flow, the tungsten immediately gets consumed due to the reaction with oxygen. Let's watch it. Now that's a thing of beauty, isn't it? All right, let's move on. So we saw a bunch of arc starts and high frequencies very easy. Lift arc, if you do what I tell you to do, works good. And well, scratch start doesn't work too well when you don't have shielding gas turned on your machine. And that's simply because I can't do scratch start with the Dynasty. Unfortunately, it doesn't give you that option. Now, I could have busted out my gas valve torch, which I don't have handy, and shown you it, but the same thing holds true kind of as lift start. I used the filler rod and scratch it between the tungsten and the workpiece. The difference is lift arc, you have a lower voltage at first. With scratch start, you have full amperage. So full power, and once you strike it, you're more than likely, if you're at like 200 amps, you're probably going to blow the filler wire up and probably melt some of it on the tungsten. So your scratch starts fair amount harder. Anyways, you saw all of that. The question is, what do you do with that? Well, since this is a first lesson and you're trying to teach yourself how to do TIG, you need to do arc starts. Imagine that. So off camera, I did, I don't know, 20, 30 of them. And that's what you need to do. Whatever plate you have, thin or thick, you need to fill up half of it, at least to put a hard number on it, 200 arc starts. So you want to start the arc, slowly taper on the gas pedal so the more heat, and then slowly taper off, and then go through and do a couple hundred of them. I know that's a lot, and you don't want to do it, but unless you've mastered starting arcs with your machine, everything else is going to be far harder than it should be. So if you don't have a foot pedal and you're just doing lift arc, so be it. 200 arc starts. Start the arc, and then once the puddle's there and you feel confident that you're controlling it, snap out of it right away. When you get a really good handle on that, so at least 200, you can then do what I call just a fusion line. And what you're going to do is create your little molten puddle, and then you're going to slowly drag it along and create more or less just a line of fusion, a line of what you were melting without filler. When you can do 20 to 30 beads, just like you see here, without filler, perfectly straight and consistent in width, then start concerning yourself with filler. I'm not going to cover feeding filler in this video. The next one that comes out, I probably will in depth to give you guys a lot of tips on that. But you need to master the simplest first. That way everything else becomes easier. So in conclusion, what did we learn today? Well, we learned how to start the arc and how to make little dots on a plate and little fusion lines. And I know that probably doesn't seem that useful to you, and I made the job that I'm requesting you to do, this homework, pretty easy looking. But the truth is when you're learning, you're going to end up dipping your tungsten a lot, and you're going to have a lot of problems. So this is one of those things that if you could spend 2 whole plates the size of this just doing it, in the long run it'll benefit you. The more time you spend mastering the basics, the easier the impossible becomes, is a way to look at it. So it really pays dividends. Spend as much time practicing this as possible. And in the next video, I'm going to cover a lot to do with how to feed filler rod to your benefit and to get your filler wire hand up to speed. So we'll cover that in another video. For right now, you need to focus on this stuff. Now, if your tungsten gets dipped, grind it down and clean it. Don't try and keep welding and making spot welds and all of that. If you dipped it, nothing good comes out of it. You need to focus on maintaining the correct arc gap. With that said, thanks for sticking around for the video. Until next time.